So any questions? Yeah. Yesterday we looked at the functional interface and lambda expressions. Right? We also saw the standard function interfaces. Just the list we have seen. Yeah. And yeah, and some exercises were there, right? So any questions? Okay. See, yesterday we had seen the whole set of functional interfaces, which are the standard functional interfaces. Java.util.function package. If you want, you can recollect. Here it is like. And this was the whole list we had. And you could get the PDF file for this, right? Yesterday's presentation. And from that GitLab link, you could download the yesterday's PDF also, right?
Yes, sir.
Okay. Okay. So anyone has questions? Yeah. Anything from the exercises if you want to have? Okay. So before we begin, yeah, we'll have there are a couple of questions for today. Just the new thing, something very common. Let's see. Okay, let's start this. Okay, so here's the question for today. Yeah. Fine. So line 3 says let's assign null to S1, and line 4 says S1 dot format. Okay. Invoking format method, passing hello world just some string as a parameter, and format method returns a string. It's a method of the string class. Okay. It's a static method of the string class, so which is returning a string. So now, yeah, these are the options you have: A, B, C, D. Yeah.
The reference is null, so like null is not correct section.
Okay. Error at runtime at line 4. That is C. We are talking about C, right?
Yes, I'm not like.
Yeah. Anyone else has any other answers? Anyone opting for A or B? D, A, B, D. Okay. So most commonly, yeah, people think this is going to be C. Yeah.
For option A, I think comparison has zero successful.
Okay. Yeah. Yeah. Anyone else has the same option? Option A.
Sir, it will search in first S1 object, then it won't find, then it will search in class. So
But S1 is null. The whole point is S1 is null, right? S1 is null, so where does it find then?
Option B.
Maybe
Option
sir in
B.
class, string class.
Okay, I'm not getting the exact point when you're saying what is to be searched, format method or search for. See, one thing I mentioned was that format is a static method. Okay, fine. So do static method involve an object?
No, sir.
No, right? When they don't require an object. So when you write it as s1 dot format, how should this have been written? How should line 14 have been written, knowing that format is actually a static method? How would you have done it? String dot format. Okay, fine. See, the compiler allows you to use a variable of a particular type instead of using the type name, right? Instead of saying string, though even if you say s1, it still understands that, okay, what you mean from s1, it will say, okay, s1 is of type string. And since format is a static method, though you write it as s1 dot format, it actually gets resolved into string dot format. Okay, fine. So yes, option A is the correct answer. Okay, it would compile and execute successfully, fine. But yes, initially, normally some developer looking at this code, oh, you're invoking method on a null. Okay, fine. So that the normal tendency would be to say, oh, this is a null pointer exception. Fine. But so keep in mind, static methods, yes, they will resolve. If there is a static method which is being invoked, fine. It's not the object, but it is the class name which will be resolved. Okay.
So, sir, like compiler will resolve for us.
Yes. See, static methods are not invoked on objects. We know that, right? So if you are saying S1, okay, its format is not on S1 basically, right?
Yes, sir.
So S1 is only used to find out the type. Oh, the type of S1 is string, fine, that it should be string dot format. Okay. There's so many things compiler actually resolves for us many times, and we just use it like this. Okay, there's one more question, again related to null only. So let's have one more question. Yeah. Again, yes. First line up to line 4 is fine, right? Okay. But then 5 and 6, these two lines are also introduced. When this is passing null to a method. So right? You're passing S1, which is null basically. One is you are doing it in println method, other is you are doing it in the printf method. So yeah, what are the answers? B, of course, is which one?
Println prints null, but printf pointer.
Null pointer. Yeah, you get a null pointer right now. You get null pointer? No. Line 6. And so runtime error, null pointer exception at line 6 basically. Okay, fine. So yes, methods, when you are yeah, println method would print null. Okay, so so there is conversion to null. Okay, a null reference can be converted into a string like this. Okay, see one thing. Okay, let me. Yeah. Okay. Okay, this is about string conversion. Okay, just a small thing about string conversion. How do we convert to a string? For reference types, yeah. Any reference type, how does it get converted into a string? To string, right? Okay, so if you have a value x, okay, whatever the type may be, and some ref type, okay, x is my value, fine, whatever it may have been, okay, it is assigned a null. Not null, it may be assigned anything, so we don't know what it is assigned. Okay, now if you say x dot toString, fine, you know that this should convert it into a string. This is what we normally understand. Fine. What happens if x is null?
Object class toString will be executed.
Even if x is null? Okay, let me show you now. Okay, let's do it with string itself. So we have string, yeah, s is equal to null. Okay, fine. So what do you think? S dot toString.
Error.
Error. So how do I convert it into a string? I am not sure whether it will be null or what, right? But I still want, I don't want an error, but I want it to be converted to a string. Is there any other way? Other than doing a toString. How do I get it converted into a string? So I'll say, okay, string x equal to, and I want to do something with s so that I have the string conversion for s. Even if s is null, it should work. Whatever the case may be, right? Any idea? No one? Okay. Just concatenation with a empty string. So string conversion, you can always actually be doing it like this instead of doing a toString. Okay, so this will take care. If s is null, yes, it will be converted into a string which says null. If s is non-null, it will invoke toString and get the value. Okay.
Yes, sir.
So string conversion, if you want, yeah, you can always try the concatenation, right? Fine. And so not x dot toString, we would do x plus for string conversion. Okay, Fine. So anyone has tried exercises and has some questions? Whatever we had done yesterday here, whatever changes, that I had pushed on the GitLab. So, and so you could have actually picked up from there and proceeded further. Yeah.
So there is a to-do like get rid of balance field from the account section.
That one is after we look at streams. Then it will be easier. But yes, of course, someone can do it even without the stream. But with stream, that exercise is meant for after stream. But anyway, okay, so you have tried that.
Yes, sir. Actually, I have entered over the like passbook and added all the balances.
Okay. Okay. So going through the passbook and getting the net balance, right? Summing up the net balance. Okay, good. Fine. So that's the way it could be done. Yes. But it would be easier with stream. We'll see. With stream, it would be a single line statement. So if you, yeah, we have to look at streams. Okay. Okay. Coming to the to dos. Yeah. Implement the comparable, that was already done, right? Local date, yes, we'll come to that later. Okay. Add the method called get transaction stream. Okay, that can be done. Has penalty. Yeah. Okay, so you have tried this also, this one also. Okay, because this is also meant for something to be done once you know the streams. Okay, but if you have done it earlier, you will actually see the difference, how simple it makes, how simple the streams will make it. Okay, to do these things. The whole point is these would be single line statements most of the time, 1 or 2 lines. Okay. Okay, so anyone has questions now? And some things to be done in the bank. Yeah, in the bank, we have to use map now, right? For the bank class. To do, update the class to use a map. Okay, so instead of the array which we have, right, we would like to use the map. Okay, let's see how we do it. And okay, just one more conceptually, one more thing. Okay, is there a mistake if I do it like this?
No, sir.
Okay, and you are aware of this, right? You can use underscores in a integer literal. Yeah, this one again here I have shown already. Yeah. Okay. So it improves the readability. Okay, fine. So for the purpose of improving readability, underscores have been allowed. That's from Java 7 onwards. Okay. Yeah. Okay. So I'll make the change. Use map instead of this one. Okay. What will it be? If we want a private, a map of long, right, comma, account. Fine. Long for the account number, okay, and the corresponding account object. And let's call it as the account map equal to new. Implementation classes, you can use hash map, fine, or okay, let's say initially we use hash map. And so this is the change we initially make. We'll need the import for these. Okay, map and okay. Okay. Hash map. Okay, so we okay, so what are the other changes now? Once we have this, yeah, where is the change? account type, okay, account dot create
Open accounts.
in open account, right? What about the create? Yeah, open account. So account AC is equal to this you have created, but then here this will change. Okay, fine. There's no array. Instead, now what we should be doing, this dot account map dot put. Okay, fine, we'll put it. And what do we put? AC dot get account number comma AC. Here, fine, the account has been created, so that doesn't change, all that thing remains the same. Okay, fine, but wherever the array putting into array, now instead of array we are now putting into the map. Okay, get account, yeah, account is equal to, so this also changes. Fine.
Yes.
Okay, so this is simple, right? We'll just change it to account AC is equal to this dot account map dot get account now get. For that given account number, use the get method on the account map, and that should return the account object. Okay, and then this remains the same, and I don't think there is any other change anywhere else. Yeah, of course, there will be one which is in the list accounts. Yeah. Okay, list accounts, how does it change?
Accounts dot values.
Okay, so we'll have collection, right? Or okay, for loop you want to change there, account map dot values. Yeah, and we don't need the check here then. Okay, fine, we won't be finding a null, right?
Yes, sir.
Okay, let me do one more thing, just like all the previous change. Here also, when we are making a change, we'll do a commenting part. Fine, we'll not remove anything. Okay, and we'll just simply comment account map dot values. Okay, right, I think this should we can just compile and check, so this should be working. Have we used anything? Map, hash map collection. Okay, let's check. Okay, so this compiles, and anyway, if we run, there's not going to be a change. Java minus cp dot backslash bin, and this will be bang dot test bin. Okay, some name and some number, and this is working, and so our code is working. Okay, add method called get account stream. Anyway, that is after we come to the stream. Okay, so these changes were fine. Okay, changes in the account, changes in the, we have changed anything in account today? No. We haven't changed here, right? Yeah, just one more point here. Let's look at that list which has come out. 1 second. Okay, look at that list which has come. List of accounts. Is there something wrong about this list, or is this okay with the list? Would you like something better than what is coming here? What do you feel is could be considered wrong in this list? The ordering, account numbers. Is it ordered by account number?
No, sir.
See, map is unordered, right? Okay, sorted map will be something which can get sorted on its key. Okay, so if you use a sorted map, the implementation of sorted map is the tree map. Fine. So simply using tree map can change that. You have used a hash map, and when you create a tree map, okay, fine. As a parameter, you could be passing a comparator, not necessarily. In this case, our key is long, which is already comparable. So if it's comparable, then it's fine. Otherwise, you need to pass a comparator. Okay, and even if it's comparable, you want it based on key some other attribute. Okay, not the natural ordering of the key, but some other attribute of the key. Then you need to pass a comparator. But ordering will be based on the keys. Okay, so tree map is implementation of a sorted map. The constructor can take a comparator as a parameter. Okay, but that comparator is for making comparison of the keys. Okay, fine. Now we can just compile and check again. Okay, now it's coming correctly, right? Fine. Okay, so let's proceed now. Or yeah, any questions otherwise? Yeah. It's about creating comparator. You have any questions about comparator now? Because our next topic is actually starting with that only. Anyone has questions about comparator? Yeah. Okay, no questions. Let's proceed then. Okay. Okay, so the miscellaneous classes, what we are going to look at are mainly three things. Okay, one is about the comparator. That's an interface basically. Fine, it is already exists. It's not a new one, but there are a lot of from Java 8 we understand static methods and default methods were added. So this interface has been updated and it now has a lot of static and default methods. Okay, so what are those static methods? And they are quite useful to us. Basically, they are useful for creating objects, static methods especially. Okay, so creating a new comparator, fine, that's what will be how do we create a comparator? That will be what we'll be looking at here. Other is optional. Fine. When we started, took the example of null pointer exception. When you know that our two exercise, two questions which I had, right? They were all they were both related to nulls. Okay, more closer to getting that null pointer exception. Right. So here is one particular class which was introduced from Java 8. One of the purpose of this was to somehow try to get null pointer exception is actually the most common exception in Java. Okay, it's the most common thing. Okay, so how do we try to minimize those null pointer exceptions? So it's an effort towards that. Okay, optional, using optional. Okay, and then we have something called the summary statistics. There are, as I said, for primitive types we mainly deal with int, long, and double, and therefore we can, if you have values which are int values, and you want to get the statistics for a number of values. Statistics will be like what is the count, what is the min, max, average, okay, and sum. All such find these kind of statistics so we have a class to help us maintain those statistics. Okay, and so for int, long, and double, so that we have these three classes. So these were introduced in Java 8. Fine. Okay, so starting with comparator. And okay, then what we'll be looking at is the streams. Yeah. When we want to understand streams, that's some in topic. Okay. Comparator factory methods. Yeah. So mainly there are three things here. Okay. So let me start with what are the methods of comparator. Okay. So starting with the comparator. We understand we have the interface called comparator of T. Okay. So given a comparator, this has static methods for creating a comparator. How do I create a new comparator? Static methods. See, if someone uses the term factory methods, right? I have used the term factory methods. Do you understand what is the meaning of someone saying factory method? Factory refers to creation basically. So you have static methods which would be useful for creating objects of a particular type. Static methods are always used without object, right? Okay, and then so if you have a class which class mainly it's you have many times you were having classes where you have static methods which in turn create objects for us. Okay, we call them as factory methods. Okay, so static factory methods are there. Let's look at the static methods useful for creating objects. How do we create a comparator? So these methods, so we have a public static method. Since it's a static method, that particular T which is here, right, in the declaration of the interface is not going to be available to us. So whatever, now if we are writing it, it's like we are saying, okay, if I'm putting T here, it's not the T of the comparator. Fine, it's a independent thing, right? This is a generic method having its own type parameter T. So it has two type parameters T and U. Okay, but U has a bound. Okay, U extends comparable of U. Okay, fine, you get this, that we have a method where we are thinking of two types. One is T, other is another type called U. But U is not just any type, U has to be some comparable type. Okay, so given these, the whole point here is why we are having this method. It's for creating object of a comparator of U, of T. We want a comparator of T. So if you want to create a comparator of some type T, Fine. We can create, we have a static method called comparing. Okay, fine. I'll put the parameters in the next line. Okay, which has parameters as the first parameter will be it has just one parameter only. It needs a parameter which is nothing but a function which for a given t can return an object of type u. Okay, fine. So I'll call it as mapping function. Right? So this is one mapping from t to u. It's a mapping. Okay. So this creates a comparator of t. So what exactly this means? What is function from t to u? Yeah, creating a comparator. Method name is comparing here. I can keep them together so you understand. Yeah. How do we use it? Let me use it now. I think so. If it's a static method, so I should be saying comparator dot comparing. What am I interested in? I'm interested in a comparator for account class. Okay, so think of t as the account because that's I'm interested in a comparator of t. Okay, we have the method returning comparator of t, right? And okay, some variable name. So you want it to be comparing by names. Comparator dot comparing. Okay. And what should be the parameter here? Yes. I need a function, right? When it says function, input type, parameter type is t. That means it's an account. It should be returning u. What is name? String. Fine. So given a account, I want the name from that account. Okay. For an account, I can get a name, which is a string, right? And string implements comparable. So yes, u is, if u is considered as a string, it is implementing comparable already. So it satisfies that condition. Fine. If u is considered as string is comparable. So this is fine. It is part fine. It's according to the point. It's not violating the bounds. So yeah, what should be used here? Now tell me. What do I write in this?
Account column then get name.
That's it. See, you have got a comparator which can compare by names, account objects ordered by name. Clear? So if you see now, if you want, you can now relate to that sort, the invocation of sort, arrays dot sort, right? Okay. It was like, oh, we have all the account objects, and or bank dot get accounts. You don't have the account objects directly, no? Anyway, so if you had an array of account, okay, let's call it as accounts, comma, by names. We can make it names. Singular is better. Okay. Here I am assuming accounts is a array of account object. Okay, fine. Let's look at one more variant of this. Now, see, so here it is simple. Account has one of the attributes which is a comparable type, right? String was the attribute, type was string. But suppose you don't have it as a comparable type. If this constraint is not there, then it says you give me two parameters. Fine. Your attribute, u is the attribute basically. Your attribute is not comparable, but do you have a comparator for you? So if you pass two parameters, this can work. Okay, fine. So here again we can have an example in our case also, in this case also. And okay, let me show how it can be done. Yeah, because it's almost the same thing. Okay, by name, ignore case. Yeah, it needs second parameter. What is the second parameter? If I have to ignore the case, I need a comparator, fine, which ignores the case. And in string class, we have a in the string class we have this comparator. Fine, there is a static variable. I'll show you. Okay, let me show from the Java library, Java API. Fine, I'll show you where it is, and then I'll use it here. Okay, or okay, let me put it string dot. Okay, so this is how it is to be done. See, creating comparator, right? In this case, we are not using that, okay, a string is actually a comparable type. No, it may or may not be comparable. I'm interested in specifying a particular comparator for the string. Okay, this is a comparator available in the string class. Let me show from the API documentation. Yeah, java.lang package, sorry. Okay, and here classes and interfaces, we go to the classes and just ask for the string class. Okay, here's the string class, and in this we have the fields, and you can see this is the field. Static final comparator of string, case insensitive order. And so this is a ready-made comparator available as part of the string class itself. It's a static member of the string class. Okay, so if you want case insensitive comparison, fine, ordered independent of the case for string, use this particular comparator. Okay. Okay, arrays dot sort. Okay, fine. This is how it would be done anyway. Yeah. Next one, right? So we have seen two methods, two forms of the public static method with type parameter t. Okay, and returns a comparator of t. See, in the earlier case, we had the attribute, fine, because always a function is being used. Function whose input is t. Fine, you want a comparator for t. Okay, so given a t, extract one attribute, and we would like on which we would like it to be ordered. Okay, and so it understands. I'll create a comparator accordingly. Okay, now if that attribute happens to be of type int, long, or double, then we have three different methods. Okay, name of the method is comparing int. Parameter would be to int function of t. Okay. Let's call it a mapper. Okay, fine. So just like this, we have two more methods. Okay, when clear, these are, so it's a simple thing. In one example, if you want for this also, we can do this. A comparator for account, okay, by balance. You want it to be ordered by balance equal to comparator dot comparing long. Right? The type is long, balance is of type long. And what's the parameter? Yeah, get balance. And so that's how you create a, yeah.
So comparing can also work with that one. So why we are comparing long with?
Acha. See, it is primitive type long, right? If it's a wrapper object long, then fine, it would work. Okay. But for primitive type long, you should use this. Otherwise, unnecessarily, it will have to do the boxing conversion each time. Okay. When we are having a primitive type long, right? What is the get balance method saying? It returns primitive long. Look at this. Right? Balance is primitive long. Okay. And get balance accordingly returns primitive long. Okay. So when we have primitive type long, int long or a double, right? These are the methods to be used. Okay. So the whole idea here is, yes, basically any kind of attribute you may be having, right? So you have a function is having parameter which will be of type of the element you want to order, fine, and it should be returning the value, the field on which you want it to be ordered. Yeah. So getter method, right? And using method reference helps us, right? You can now see this is looking much better than if someone had written like this. Compare like this. Which one looks better? Fine, the method reference, right? Okay. So we normally try to prefer using a method reference, but it's not always going to be possible to have method reference. Okay. Okay, so I'll put it here like this. Fine. So same way, fine. So clear about how to create a comparator using the these methods. Okay. So these are the comparing methods. Then we still have more methods. Now, if there is a class which is already implementing comparable, in our case, even account is implementing comparable. Okay. So if you have a class which is implementing comparable, then creating a comparator, fine, of t. So, okay, we have again public and static method. Let me continue with that. So we have public and static method, your t. But of course, though I have not put the constraint, t extends comparable of t. Okay. In that case, you can say we have a method called natural order. We even have another method called reverse order. Okay. And so these are static methods, fine, to help us create comparator. If you want, I can put that constraint. T extends Okay. Okay, now let me show another thing. Fine. Say you have an array. Okay, so sorting of an array is there. Now, suppose I have a string array. Okay, and we want to sort a string array. A string array names equal to, and we create an array like this. And yeah, okay. And someone says we have a null. We have yet another null, and oh, we have some array like this. Okay, and we want this to be sorted. We want this to be sorted. Yeah. Okay, I'll show it in JShell so that you can see it in action. And let's use JShell. And let me paste the code here. Okay, fine. I want names to be sorted. So do you think this will work? What happens if I say arrays.sort and I simply say names? It's comparable, right?
Yes.
So what will happen? Do you think it will be able to sort? Okay, let's try. Fine. It's finding null. Okay, because it finds null, it is unable to sort. Okay, so if your elements have got null elements, you can't be sorting. You are not able to sort them. Maybe even if I try something like comparator dot natural. I want the natural order. Okay, it returns so I'm passing comparator also, and then also same thing happens, right? Yes, same problem. So nulls are there, then how do I sort them? Okay, so for this we have a method. Okay, so creating, we call them as null friendly comparators. So comparator which can handle nulls also. Okay, so we have public static method returns t, type parameter t is there. It would return a comparator for t. So comparable, this is comparator. No, sorry, that was correct. It was the bound. Yeah, I was thinking it's a return type. Return type here is correct, comparator. Yeah. Okay. Yeah. So this has to return comparator of t. Static method here, and name of the method is nulls. First, there are two methods. It says if you already have a comparator, I will convert it into a null friendly comparator. So if you have a comparator, okay, it can be converted into a null friendly comparator, where you will get nulls to be sorted initially, or you can make it nulls first, you even have a method called nulls last. Okay, so if you want, we can just use them here, right? So comparator dot natural order, that's giving me a comparator. I can say comparator dot nulls first, and as a parameter, that's my comparator. Okay, and you can now look at names. Yeah. Nulls first, and then it has sorted. You can make them nulls last. And so nulls go to the end. Okay. Clear? Creating null friendly comparator. That was the whole idea. And so these are static methods to easily create comparators. Now there are still more requirements of comparator. There are more cases. Let's continue with our slides here. And natural comparing and variance of primitive types, we have covered that. Natural order and reverse order, those two methods, null friendly comparators. Okay. Other default, now coming to the default methods. Okay. What is the default? Yeah. So let's look at the default methods. Okay. So for a given, now it's a default method, so it's on an object. So given a comparator, the whole idea would be something like this. See, you have two comparators. Okay. We have something by name. Okay. We got one comparator called by name. Okay. Fine, that's one of the comparator, and then we have a comparator by balance. So you can do something like this. Comparator of account, okay, by name, then balance equal to this. Fine. So we have this method, default method called then comparing. Okay. So we have the public default method which returns a comparator for t. Okay. And name of the method is then comparing, where it takes a parameter as another comparator. Okay. So you have a comparator C1, you have another comparator C2, C1 dot then comparing C2. Okay, that can create another comparator. So when you want to compare, like this is, it is by name, but if name is equal, then you order it by balance. So secondary key. Okay. So multiple such keys can be combined by just saying then comparing, then comparing. Okay. So this is one default method where we have the then comparing. Okay. Then comparing has been overloaded also. How it has been overloaded? It says fine. We have a type parameter u as well, which extends comparable of u, and then it says, okay, you don't pass a comparator, you don't have a comparator, but then you give me a function so that I can create the comparator. You recollect that comparing method, right? It requires from t to u. Okay. So if you have the mapper function, fine. For the second attribute, yes, we can have it, right? Okay. So it's not, so similar variants are there. Then comparing int, then comparing long, those methods are also there. Okay, fine. There is also yet another default method. You just want to change the reverse the ordering. So we have a default method to return a comparator of t. Method name is reverse. So on a comparator, just say reverse dot reverse and should be giving us the reverse ordering. Okay. Anyway, but reverse is the default method. Okay, let's look in the API. Yeah. Let's go to the comparator. This is that comparator interface and the methods which we have, the static methods. Okay, here this is that comparing method where u extends comparable of u. Fine. And here when it is not comparable, then you have to pass a comparator. Second parameter is to be passed. Fine. Otherwise, we always have those comparing int long double. Okay. Natural order, reverse order, nulls first, nulls last. So these are the static methods. We may have a look at the default methods here. Reversed, it's not reversed. The method name is reversed. Okay. Then comparing takes a comparator. Okay, that's fine. But you can even pass a function, or you can pass function and a comparator. Fine. Or you can say then comparing long, to long function, to int function, all those things. Okay. Here, so when you want to combine multiple keys and create a comparator which compares based on first attribute and then second and then third and so on. So that can be done by using the default method then comparing. Okay, you can build and create more sophisticated comparators. Yeah, so these are methods which were added in Java 8 comparator for creating comparators. Static and default methods. Okay. Yeah. In test account.java, right, there are to-dos there also. So I think it's about creating comparators that you should be doing. So you should be, I think this now you should be able to easily do it. Fine. And if you look at that to-do in the test account.java, it's all about sorting. Want to see what are those to-do? This we have not done. Yeah. Okay. Here, these are the to-dos which need to be completed. Create a comparator to order by name. And we know this already. Order by balances. Order by natural ordering of the account. Okay. So what you need to do is just add the code. See, what has been done here is, okay, the message has been given that we are ordering after, and we are printing after ordering by name. Okay, so before this you add the code for ordering them by name. Okay, so accounts is our array which needs to be ordered. Okay, or I'll show for one. It's something like this. Yeah, and then this. So just add this, similarly add a single line or maybe multiple lines as needed before the system out println. Okay, and then display accounts. So, and so fine, I expect you to finish all these to do. These are all related to sorting only. Case insensitive, name and then balances. Fine. Sorting by type of account. Okay, then on balance. So think on that also.
Sir, for this thing, I have added a get type method in account section.
I didn't get, sorry. You have added?
Get type method.
Okay, okay, okay. Fine, that is okay. Good. Or, okay. Even if it was not added, right? Can you still do it?
Plus.
Get class, right? Method. We have the, you know about the get class method, object class. Are you aware? There is a class called class, capital C. Okay. Yeah. You are not aware, I think. Yeah. Okay. 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 We have this public final. Method is final. Returns a class. Okay. It says question mark. Okay. Fine. I'll just leave it. And there's a method name. Method name is get class. So there is one method like this. What does it return?
The class.
Yeah. So you're aware of this class?
No.
Okay. Fine. Suppose I'm writing equals method, right? For how do I bring it? Okay, let me explain in the book. Yeah. You know what is, there's something called class loading. When is the static, you are aware of static block, I hope, right? That in a class definition, suppose you are writing some class, okay? Okay, in this you can have a static block, right? We know variables are there, but you can have a static block. Aware of this static block? Yeah, class can have a static block. Class can have variables, right? Instance variable and static variables. Class can have methods, instance methods and static method or class methods, right? Class can have a static block. Okay, let me ask, what is the purpose of a constructor?
To initialize the
Instance variables, right? Now you understand that your class can have instance variable as well as static variables.
Yes.
Okay, now if there are static variable which is to be initialized, then do we have only one option, that is yes, assignment, right? Fine. I'll say, oh, I have a private variable, okay, private variable of type, okay, I'll use long currently, okay, start time. When did the application start? Equal to, and then what should I do? Oh, I don't want to assign like this. I don't want to do equal to like this. I just want to declare it, okay, and then whenever my application has actually started, right, okay, I would like it to do the initialization. How do I initialize my static variables? Giving some initial value to a static variable. Instance variable, I initialize from the constructor. Class variable, how do I initialize? Suppose this value of this variable has to be read from a file. You have to read from a file and then initialize the value. Fine. That's where a static block is useful. Fine. A class can have a static block. This executes when the class is loaded. Okay, so it will execute only once when the class is loaded. Class will be loaded once. First usage of your class and the class is getting loaded. It doesn't know how you are using. But one thing, declaring a variable is not a usage of a class. Okay, you create an object, you call a static method or any such thing. The first such usage of a class would prompt the runtime to load the class definition. Right? What is meant by loading a class? What do we mean by loading a class? See, you write a Java code. Yeah. Huh? Yeah. Go ahead.
Add to the memory.
Fine. What is to be added to the memory? It has to read from the class file. The definition of the class has to be read and kept in memory, right? Loading means, yes, it has to keep in memory, right? Okay, class definition. What is to be kept in memory? The class definition. Where is the class definition? it's in the class file, the compiled class file. When corresponding to every class which you are defining, there is a class file created, right? Every class definition, you get a class file. Every interface definition, you get a class file. You know this, right? Dot class file. On compilation, you get a dot class file, right? Okay, so what exactly happens is, it loads the entire class definition into memory. Loading a class into memory is nothing but it is the act of creating an object of the type class. There is a class called class. Object of this class are having information about a class definition or an interface definition, about a type definition. They have information about a type. An object of a class is representing a data type. So every data type has its own class object. Okay. For every data type, there is a class object. So there is a class object for the class called string also. There is a class object for the class called account also. Okay. You define an interface. Oh, you have a class object for that interface also. Fine. Clear? So that gets created when it is loaded, basically. So class loading creates an object of class. And class has got a lot of useful methods. Okay. Maybe they are slightly advanced, but let me explain. Just give you a small example. Given a class object, that means it's a class definition. You can ask for, okay, what is the name? It's a type definition, I'll say. Information about the type. So what is this data type? Right? So class object corresponds to every data type. So you can say, oh, get me the name. So there's a method called get name. Class. I'm talking about method of the class. Fine. Class has a method. Fine. What has a name? Fine. And what else does a class have? When you define a class, what are the things you are having? You give a name, right? Then class has a superclass. Class has variables. Class has methods. Class has constructors. Fine. You may like to know whether this class is a final class or not. See, or whether this type itself. I say it is for a type. So whether this type is the class object is for an interface. Is interface. You have method like is interface. So you have methods which is giving information about a type. So later I would just like you that you may fine, just if you are interested, you should go and study what is this class called class. Fine. This is useful for what we call as a reflection API. Corresponding to this, there is a separate package java.lang.reflect. Okay. Anyway, a short thing, a few things related to this class. Just knowing that there is a class called class, right, which represents every data type. Okay. One important thing which I would like to now put here is, right, we can have a class object. Any data type. So every data type is its own class object. Okay, remember this. Okay, by using a what should I call it? A notation or something like this. Okay. Okay, I'll just write some examples so you will understand now. So for example, you'll say I have a class object for C1, some variable name equal to, and I can even use like this. You want it for the primitive type? Or okay, you can say account dot. See, class here is a keyword. Remember this, class is a keyword. So don't say it's a member of a static variable of the class called account. No, it's not the case. Okay, that's why I've said it's a notation. Fine. So you use dot class after any data type and you get the class object for it. That's also valid. Any type name. Fine. It's an array type now. Fine. So there is a class object even for array types. So any data type you think of, there is a class object for it. Okay. And given any object, you can ask for what is the class object for it. You have said account AC equals, and I don't know, I might have said new current account or savings account or whatever, right? I don't know, right? So you can ask for, okay, AC dot get class. Is it equal to you can ask for this. This is a Boolean expression. Current account is my name of the class, right? A type name, right? So I can use any type name dot class. That's a class object. And get class returns, given an object, it will tell me what is the class object for it. So this account, if it is created with current account, then this will be true. If it is created as a savings account, this will be false. Okay, so there are a lot of usages. So just knowing about this class called class is important. Okay, fine. Okay, we can continue with other. So just explore, and later you can just try exploring this class. And that static block executes whenever your class is loaded. Okay, comparators. Why did we go there? What prompted us to go into this class?
Sir, can you please implement the last push?
Which one? Acha, for the last one. Okay. Yeah, now get it. Yeah. Here. Right?
No, sir. No, that's not by type.
This is the test account. So you want it to be sorted by type, right? Okay. So we can use, okay, we have written the code for here, arrays.sort. Okay, I'll just copy that line and we'll just change how we create the comparator. Okay. Here we may have, it won't be a single method invocation, so we may be using a lambda expression. Okay, fine. What we want, given an account, I need to give out a comparator, a comparable item. So for a given account object, I should be able to return the type of the account as a string. If I can do that, that should be okay.
Yes.
Given an account, AC dot get class dot get name. That's it. And it returns a string. Okay, converts it into a string, and string it will be sorted. So type, then sorts them by balance. Okay, so this is your first comparator, or basically you want it in multiple steps. We can do it in 2 steps. So this is how it should be by type. Okay. Oh, I just in a hurry I just put the dot. Okay, so this is by type, and then we can have comparator comparing by there's one extra, I think. Yeah, this is okay. By type dot then comparing, and then it is on balance. Then comparing, we have by balance. No, we haven't created. So if you have not created, we can do something like then comparing long. Okay, and this will be saying comparing long would be account brackets check करना है. I think it should be okay. Okay, fine. Let's compile. What have we missed on? Bracket. I think there's some bracket missing. It's on that same line, huh? Line 70. Yeah. Yeah. One second. Which line? This is line number. One second. Okay. Okay, it's that same comparing the one which we have used, right? Oh, we have it done that by type, right? It is done. Yeah, by type is there. So by type is not a problem. Let's create it separately, then, independently. Okay. Comparator dot of account by balance equal to. Okay. Let's try that syntax also. By type dot then comparing long. Balance that should have worked. Then comparing long. Does it simply need a cast or? Acha, okay. Yeah. See, what has happened is by dot, we have simply added this. This is not needed. Initial part, this is what is wrong, basically. Okay. We forgot to remove that part. Next. Yeah, this is okay. Fine. It's a default method. So by type dot then comparing long and account colon get balance. That's how it is. Yeah. Okay. Fine. So this is sorted by type and then balance. Is it? No. After sorting by type then on balance. So you should see this. It's all the current accounts and then the savings account. and but we don't have yeah, fine. Current accounts sorted by balances, right? And even savings account sorted by balance. Yeah, it's working. Okay.
Yes. Yes, sir. Thank you.
So then comparing, that's for, so when you have multiple, you'll use then comparing. So you created the method called get type. Okay. And if you had the get type method, you could have done this. In that get type, you return get class dot get name. Or I'm not sure how you have done it. Yeah.
No, yes, sir.
There, actually, in the bank, I think we have the enum also called type, account type. Anyway, don't use that. This is better. Okay. Okay. Yeah. Fine. So I expect you to finish the comparators. Okay. Let's proceed and look at the yeah. There's this class called optional. The whole idea of optional, what is this optional for? What is the idea? The problem of null pointer exception. Fine. Okay. Fine. I know. I hope everyone knows what is this null pointer exception. When you get this null pointer exception, right? If you have a null and you invoke a method on, you have a null reference and you are invoking a method on that, right? Like morning we were trying s1 dot format, but of course that time it was not s1 dot format, it was string dot format. But if instead of s1 dot format, someone had said s1 dot to uppercase, okay, invoking an instance method, not a static method, then you would have got a null pointer exception. So we are talking about that null pointer exception, someone invoking a method on something which has remained a null. Now why that problem occurs basically? Okay, so why does this problem come? Okay, so for that I'll just try to explain the reason why it is a very common thing. Okay, one of the causes for a null pointer exception happens to be like this. The developer of a class, just think, there is a developer of a class. So someone has written, so let me become a developer of the class called account. Okay, and in this account class, okay, there is something like this. Okay, whatever we have, I'm assuming whatever we have done is already there, right? But suppose I decide that I also want to have one more field of type string. Name of the field is joint holder name. So there is a joint holder name, right? Account holder is there. So joint, who is the joint holder name? Now, always joint holder may or may not be there, right? The one who has written the account class is assuming, okay, if he is there, if he is not there, I'll keep it null. Okay, and then you are providing a method like this. Public method returns a string. Name of the method is get joint holder name. Okay, and what is it that you would write here? Return this dot joint holder name. Okay, so when you do this, okay, returning a joint holder name like this, right, you the user of this method, right, the one who is using this method, suppose the user of the method says, oh, I have created one account object AC equals, and created the object, and some other place he says, okay, let's print system.out.println AC, okay, joint holder plus AC dot get joint holder dot and he says, let me make it to lowercase, whatever it may be. I want it in lowercase. Yeah. So what will happen? Account is initialized properly. It's either a savings account or current account. But what happens in this statement? You have written account dot get joint holder name. Okay, there's a method called get joint holder name. Okay, and then you're saying, okay, dot to lowercase. What about get joint holder name? The one who has developed the account class, right, he knows that this can be null. He knows about this, that joint holder name. If it is not available, it will be null. If it is available, it will be there, right? Okay, and then this is the code he has written. So it's like what it was expected was, he is expecting that people would actually do a checking. Okay, if it should be like, if ac.get joint holder name not equal to null, and then only you should do a lowercase and print it. Okay, otherwise you don't print. Otherwise you should print not available. When you're getting this problem, this code is going to create a null pointer exception. The reason why this null pointer exception is because the one who is writing this code, the user of account, is not aware about a fact that the get joint holder name can also be returning a null. He is going ahead assuming, oh, it won't be null. Otherwise he would have been doing a check. So the non-awareness about a person, about the developer, or about a user of a class, that this method is probably returning a null also. So to let the person know that it can be null, okay, this may or may not be available, right? You don't directly say, no, I will not be returning a null, but my thing is returning optional of string. I'm not returning a string now. You should change such methods where you feel there is a possibility of a null. You'll say, oh, this is an optional thing. That means there is, what is optional? What does it look like now? Okay, we'll change this code, but sorry. Okay, this is what was the code. Okay, it should have got updated too. So you might comment this and say, okay, let's change this. Okay, and we change it to, yeah. This should become optional of string. Okay, he's returning optional of string. How to create optional? Yes, we'll see that there are those three methods according to which optional object can be created. There are no constructor for optional. Okay, the whole point of optional is, you can consider it's like, I don't return the object, but I return something like a box which may contain an object, or it may be an empty one. So optional can be thought of as some kind of a box which either contains an object or doesn't have anything, or it is empty. Okay, so it either contains the string or it is empty. Fine. Now because of this return type, right, if someone says get joint holder name, now you look at the change which he has to make. Now if he writes get joint holder name, is it going to compile? Do you think this will compile after get joint holder name and he says to lowercase? That's never a method of optional class. Now it has become optional. See, the user of this method, as soon as he sees optional, it's a reminder. This is something which is not necessarily giving me a value, and therefore he is returning an optional. Here, the one who develops a class, when he is writing a method and he knows that this method in certain cases may be returning a null, he should change the return type to optional. Okay, so it's kind of a communication. to the one who is going to be using this class that I'm not, this is something which is not necessarily always having a value. Okay, I mean, that's the reason, that's the way optional is supposed to be used. Okay, and so optional should not be used just here and there. It is to be used as a return type for methods. Okay, the most common place where optional has been used is someone says, okay, for example, yeah, public, someone is writing a method, static method is okay, and yeah, we have a method to I can keep t as a type parameter. Method is to find the max, okay, from a given array of t, which is the max, right? And I'm passing a comparator for t. We understand it's question mark super t. Right? Suppose someone has a method like this. What's the return? I haven't mentioned the return. What should max be returning? What do you think max should return? I want to find the max from the array. Array is of t, and therefore the return type should be t. That's what you feel? What should be done in case array has 0 elements? There are no elements in the array. Do you have a max? Right? See, most common code would be if array length is 0, something like this. And then you proceed with saying, okay, if it is not 0, my initial max, okay, result is equal to, and what would be the result? So you should be doing a check, right, before accessing element 0, whether such an element exists or not. Right? And then you go ahead and use the for loop between for int I equal to 1, I less than array dot length, and you make your comparison and everything. When you have your comparison logic to set up the max result value and then return the result. You're finding max. Okay, so the whole point is here you are returning a null. No, don't return null. Never use a return null. If you think you are having a method where a null is being returned, change it. Change the return type to optional. And don't return null. Now you have to return optional. That means, how do I create optional? Optional.empty to create an empty one. Fine. And here return fine. We have these static methods in the optional class. There is a method called empty to create an empty optional. There's a method called off to, for a given object you should be able to create the optional object which contains that object. Okay, so here it matches my return type of option. Fine, getting the point? What is optional? The purpose of optional. Yeah. Yeah, any question on optional?
So then what's the return type of optional.empty?
Okay, so let's look at the static methods. Yeah. 3 factory methods for optional. So optional of t has these as static methods. Off method, I think what is missing is the parameter in this. Sorry. Here the parameter is missing. Okay, I'll write the actual method signature. So optional class contains static methods. Okay. Optional is a class in the java.util package. Okay, all of these what we are discussing are all methods classes from Java util package. Optional of t, static methods, 3 static methods only. Okay, so first one is public static method returns. So how to create an optional? Okay, you have type parameter t, returns optional of t, name of the method is empty, no parameters. Name of the method is of, parameter is of type t. Okay, and there's again another one, this is of nullable. Okay, this will throw exception if null. This won't throw exception if null. Yeah, so 3 ways to create an optional. There are no constructors available in the optional class. Fine. Only way to create optional would be to use the method called either empty or off. I think that O has gone as uppercase, it is lowercase in the method name. Yeah. Okay. Fine. So to create option, this is how you create. Yeah. And so does it answer your query? How to create, this is how you create.
Yes, sir, but like when the user executes like two,
If the
two
user,
lowercase.
so he won't be able to execute. See one thing, will it compile if someone says two lowercase? Once the return type has changed to optional, okay, if I have changed it to optional, will he be able to compile this? Will this compile? Because what is ac.get joint account holder name? It's not a string now.
Yes, sir.
It is now become optional. Optional doesn't have a method called to lowercase. That's a method of string. You want a string, he can go ahead. If he doesn't want to do any checking, he'll say, okay, get whatever is there in that. And dot to lowercase. Now he is actually inviting trouble. Because he has said dot get. This will compile. Okay. Dot get here is going to compile. But if it was empty, this will throw an exception at runtime.
So here we are just avoiding null pointer exception.
We are? I didn't get, sorry.
But like we are avoiding null pointer exception.
Yes, yes, it's to resolve that null pointer exception. Try to minimize that null pointer exception. Fine. So instead of saying something like get, right? Get is you know that it is not empty, then you can use get basically. But if someone without checking and he says get, fine, then he is inviting trouble. Fine. He could have also used a method called or else. Okay. Okay. See, there is a method called in the, now this is what I've used is a method of the optional. I think I'll put this in second line so it becomes available. Clear? So this is optional. Optional has a method called or else. So or else is actually returning the value. It's just like saying get. But in get, if it is not having a value, it will throw an exception if it is empty. If optional is empty, then it will throw an exception. If optional has something, it will return whatever is inside that optional. With or else, what you are saying, if it is empty, then you have this value. Otherwise, it will return according to get. So or else works like a get, but in case it is empty, you have provided a value which should be used. Okay. Okay. Fine. We have lot many methods in optional. Okay. Fine. For example, someone might even say AC dot get joint holder name dot if present. If present, then I can use a consumer. See, this is why that function interfaces are useful. Fine. Everywhere you will find function interfaces being used. Okay, I think we'll continue here and let's see the other method, some convenient methods of optional. So get method returns t, but this will throw exception. Is present returns a boolean. Is empty returns a boolean. And they are very obvious, those two methods. If present, you have a consumer. What is the action to be taken? If I find it there, then I want it to be printed. Okay. So for example, here I'll say if present, fine. So if present given a string s, okay, I want it to be printed. Okay. Whatever I was printing, that I can do. So otherwise, I just don't, if it is empty, I don't want even anything to be printed at all. Plus s. Yeah. Okay. And so this can do the job. Okay. Fine. So it's like this. Is if present, then a consumer. Fine. Consumer means you have a function. Fine. So you are providing us with a function which given a object of type t, okay, does something with it. Does not return a value. No return type. Return type is void. Fine. If present or else. Now when it says if present or else, fine. If present, then use the consumer, or else use the runnable. Okay. Fine. So you provide two different functions. If it is present, this is to be done. If it is not present, then runnable has no inputs. If it is present, that becomes the input to the function. Yeah, this is my input to the function. Okay, let's run. Or else. And here, okay. So my first parameter was this is your consumer of string. This is consumer of string. Okay. And second parameter is the runnable. Runnable says okay. And whatever, right? You can decide what you want it to be printed. Okay, fine. Then we have other methods like fine. This is like we have a method called filter. Filter requires a predicate. So if the test fails, fine. If you have an object, so predicate is like this. If it is not empty, if it is empty, it returns a optional which is empty. If it is not empty, fine, then further carry out a test. If the test passes, only then return the optional containing the object. If the test fails, then again return, though initially it was having a value, it will become empty. Okay, so filter means it can further make it empty under this predicate. Okay, predicate is nothing but a function which does a test and returns boolean. Okay, and there are other methods like this. Okay, we have a method called map. okay, which requires a function. So a optional of t can be converted into an optional of u. Okay, fine. There is a flat map. The difference between map and flat map is, in case of a flat map, the function which is required is taking input as your element in the optional object, but returns the function is returning the optional of u. In the earlier case, the function was returning u. Okay, that's the main difference. Okay. Fine. There is a method called OR. Okay, OR requires a supplier. So use the supplier to make it into an optional of t. This is one optional, and if it is empty, I will use this supplier of the optional. Okay, fine. In case it is empty, use this supplier to create the optional object. So convert from optional to another optional. Okay, this is a method which converts it into a stream. Stream we have to look at, fine, we still have to look at that stream. But getting into a stream, okay, that is one thing. Or else, I did show about or else, right? Fine. So or else you have given a value, or you can say or else get. When you say or else get, you are passing a supplier, not the value directly, but a supplier which can in turn give you the object. So supplier are methods, right? They don't require input, but they return a value. Okay. So either directly as a fixed value, or you may have a supplier function. Okay. Or else throw. Okay. So if it is empty, then throw. Fine. So this is just similar to a get. Or else throw is just like a get. Fine. Even in get, it will throw an exception. Okay. Now, what exception should be thrown, you can control that. So you can say or else throw and give it a supplier of a throwable object, the exception class. You know, throwable is the superclass of all the exceptions, right? Yeah. Okay. So this is what optional is about. Fine. Any questions now on optional? We will have methods many places in the API where optional is going to be returned. See, all this is needed because stream has all of these things. Stream is using all these things. See, yesterday we saw the function interfaces. Now you can see how they are being used. Function, we have used those function, to int function, to long function, all those things even in the comparator. Here again you are seeing function being used. We are seeing supplier also being used. Yeah, right? So fine. So now if I say supplier, you understand what is supplier. Okay. Okay, let's proceed. Now these are some summary statistics and the string joiner. Yeah, but there's one string joiner also. There are 3 summary statistics class in the Java util package. Fine, we have the int summary statistics, long summary statistics, and double summary statistics. Okay, let me explain with the figure maybe. Yeah. See, what are these summary statistics object? Okay, they are implementing the consumer. And for example, if I say int summary statistics, it implements consumer of int consumer. It implements int consumer. Fine. You know what is int consumer? It has an accept method which takes int as a parameter. Okay. Fine. So here is a, if I say here is my statistics object, right? This is my int summary statistics. Let me say this is int summary. Okay. So if you have an int summary statistics object, fine. We have method available in this. Internally, what these summary statistics object maintain there are 4 variables, instance variables inside the summary statistics object. One is a count value. Okay. Other is the sum value. Fine. There is count, there is sum, there is min, and there is max. So like this, there are 4 instance variables in this object. Okay. Initially these values will be null. Count is of type long always. Count will be a long. Okay. Sum will depend on, if it's an in summary statistics, it is long. Okay. In summary statistics, it's long. If it's double summary statistics, it will be double. Okay. Min, max, that will depend on the, if it's in summary statistics, it should be int. Fine. Okay. So now what happens is, when you consume a value by calling the accept, if someone calls the accept method and gives a int value, what will happen? The count will be incremented by 1, sum will be incremented by the value, min, max will be checked. Okay. And accordingly it will be updated. Min and max will be updated. So each time a value is given. So this is one thing which is consuming multiple values. So you can just keep on giving values to this object. Fine. And it will update these values. And it has provided methods called get count. Okay. What else? Get sum. What can be derived from these two things? Get average. Okay. Get min, get max. Get min and get max. Okay. Fine. These 5 get methods are available. Another option, another kind of method which is available is, you can combine with another one. Combine and you give, so in summary statistics, you combine with another in summary statistics. Okay, that means there is one in summary statistics which internally manages those 4 values. Fine. And if you say, okay, you update, you merge this also, you got another one with all these 4 values. Fine. It will simply, okay, count will be count will be incremented by this value, sum will be incremented, min, max, it will have to adjust. Fine. It will look at the min, max of the other one. And so this can always be managed. You can do combining of these objects. Okay. So these are the kind of methods which have been provided in the summary statistics class. Fine. It's implementing the, so you can just have a look at the methods now. Clear that what is the kind of object we are talking about now? Okay. They collect statistics like sum, count, sum, min, max, and average. Fine. 5 values, 5 get methods are there. Okay. They all have a no argument constructor and some common methods, some convenient methods for, so I have shown for in summary statistics. So accept method is there. We have a method called combine to combine with another in summary statistics. Get count, get sum, get min, get max, get average, and there's a toString. It's a nice toString. You can see. Okay, and so this is what is summary statistics. There is also another class called string joiner. Okay, this has been provided where given multiple strings or char sequences interface which is implemented by string buffer, string builder, those classes also implement the same interface called char sequence. Fine. So you can combine multiple char sequences, string joiner, for creating a sequence of characters separated by a delimiter and optionally starting with a prefix and a ending suffix. So constructors are like this, methods are this. Okay. Okay. 2 string joiners can be merged. Basically, they are maintaining multiple objects of string. Okay, and whatever you can decide on a delimiter to use, and you can decide on a prefix and a suffix. So it will create a string which has the entire thing starting with the prefix, fine, each element separated by the delimiter, and then the suffix part, prefix and suffix at the end. Okay, so that kind of string can be built, and you have the method to add element anytime, right? You can just keep on adding elements and then say, okay, now let me get it converted into a string. Okay, so string joiner is the place where you can join multiple strings and create a delimited with prefix and suffix. Okay. And if there are no values at all, fine, you can set a empty value. What should be the string if there are no values provided at all? So that's a set empty value method. Fine, clear up to this? Any questions up to this point? Because now we are taking up the next one, important one. Any questions? Yeah. Okay. See, next one is important. You will have to be attentive, and it is interesting also. Okay. Because this interface is giving lot of power. Okay. These particular streams, we would like to have a look at what is a stream. Okay, and it is a very interesting way in which it is done. See, what do you do with the you deal with arrays, you deal with the constructors, right? Not constructor, data structures, right? You have dealt with data structures. When we think about data structure, that means multiple values, right? We are thinking about multiple values. Okay, fine. So for multiple values, where do you get multiple values? You get them from arrays. You get them from something like a list or a set, right? Okay, or even if it's a map, yes, you have the methods like values, you have the methods like key set, which in turn give us some data structures, right, which are list or a set, right? So you have some or the other kind of data structure or array, or we are talking about multiple values, right? So multiple values can be there even in some other places in the library. And we are not talking about multiple values only for the reference type. Even for the primitive types int, long and double, we deal every time with int, long and double as well. Okay, so if you look at a string, yeah, what is string? A simple thing like a string. What is a string? I'm talking about multiple values now. So what is a string?
Array of characters or collection.
Yeah, fine. It's a sequence of characters. So it has multiple values. If you are thinking in terms of int, long and double, there are multiple int values. So wherever you have multiple values of some type, right, and you want to process them, what are the kind of processing we do? We find minimum, we find maximum, we can do the kind of things which we do are very standardized. Okay, Fine. But for each of the other type, for each of the types, we have to write a separate code. If it's an array, how to deal with an array? Okay, I have to write the code for dealing with an array and finding the minimum maximum. But same thing I have to again do in case I do for a set. Oh, set is different from an array. So I'll have to write a code I'll have to write a method to take like sort method is there for array. There's a sort method again which is in the collections class which can sort a list. Finding min for an array, finding min for the list. Fine. Finding min from those integers in a string. That will be separate. So you have to put the same logic in multiple methods. You are repeating the things. Isn't it? It's a problem of processing multiple entries or multiple elements or multiple values. There is a common problem about processing multiple elements. So what has been done here, they said, okay, whenever we have multiple elements, fine, wherever you find there are multiple elements, can we not have a standard format, a standard structure kind of a thing? It's not exactly a data structure, not in the sense of a data structure, but in terms of an interface, let's convert into an interface called a stream. So stream is just one standard place where we will provide processing methods to process or handle multiple values. Okay, so what is stream? Oh, stream is not a data structure. Don't think of stream as a data structure. Okay, stream is someone through which multiple values will be available. Stream is something from which multiple values are available. Okay, fine. Okay. Okay. Now stream is okay. So we have something about creating a stream initially. So stream, wherever you have multiple values, you can convert them into you should have a mechanism to convert them into a stream. So that's one thing. So what we'll be looking at is about creating streams. Okay. Streams are of types, different types of streams are there. Okay. So what is stream doing? As I mentioned, that it is about processing, right? So processing multiple elements. So to process multiple elements, it helps us to create and execute a pipeline of operations. So processing part is nothing but a step of multiple operations which you might like to perform. So to do the processing, we create a pipeline of operations. All the elements, this is my pipeline, this is my operation. First operation is this, second operation is this, third operation is this. So you can set up a whole pipeline of operations to be performed on multiple elements. Okay, so we can have streams which are sequential stream, we can have parallel stream. Okay, streams are available for generic types and primitive types, int, long, and double. So we have 4 types of streams: stream of T, int stream, long stream, double stream. These are interfaces. These are interfaces in the java.util.stream package. So there is a separate package called java.util.stream. Okay, fine. Streams have a source. Fine, initial. Source is anything where multiple values are available. Fine. So first step will be, you have multiple values somewhere. Okay, can you now get it converted into a stream? So stream is one standardized place. So it is some standard place, and now we have methods of a stream. Now the methods of stream are mainly divided into 2 kinds. We call them methods as operations. So we have got something we call as intermediate operations, and we have something we call as the terminal operations of a stream. So intermediate operations would help us to build a pipeline of operations. Fine. So intermediate operation is used for building the pipeline of operation, and a terminal operation will execute that pipeline. Okay, I'll try to explain what. So when I say source, intermediate operation, and terminal operation, let me try to give you a visualization for this. Okay. Okay, a rough visualization for this is something like this. You have some kind of a source. So this is a source. What could that source be? It could be an array, it could be data structure, it could be that string or anything, right? Something where multiple values will be available. Fine. These sources, they will provide me a method to get it converted into a stream. So when I say stream, okay, a stream is nothing but, you can think of stream as kind of, okay, so stream is kind of this outlet, okay, something from where multiple values can be extracted. That's what is a stream. Just think of stream like this. Okay, now it says, oh, when you perform an intermediate operation on a stream, okay, so if you perform an intermediate operation, so you're doing some operation on a stream and it again returns a stream. It will do some processing on the elements coming here and pass them on. That's an intermediate operation. Okay, intermediate operation is doing something on the elements coming on from multiple elements coming from a source and doing some processing and putting them further for further processing. If you have a stream, it means it requires further processing. Okay, I'll take as an example. We have the class called arrays, right? Arrays class has a method, static method called stream. So I can use arrays.stream. Parameter would be some kind of an array. So if you have an array as a parameter, yes, you can create a stream out of it. Okay, so it's like this. This could be an array, right? So there is some array for which a stream has been created. So if a stream is created, you can say, okay, this is my stream here. Fine. On this stream, if you perform some kind of an intermediate operation, for example, I'll say, I want to filter out and process only those elements which pass a particular test. Okay, so maybe something which says, okay, only those elements whose value, if it's an integer type, let's say, okay, then those elements whose values are greater than 0, negative values, I want them to be dropped. So this is my intermediate operation, which is doing the filtering part. But after filter, what does the filter method do? It returns a stream again. That means it's not finished with the processing. It is just specifying the operation to be performed. It say, okay, I still have a stream, so it's giving out. Stream is always giving out elements. Okay, stream has the ability to give out elements. When you create a stream, it doesn't give out the element at that point of time. It has just created an outlet. Yes, it has created its own processing step. So this is my step 1. Step 1, processing of step 1. You can have one more further intermediate operation, which in turn does some operation. So this is my step 2. But this operation also is returning back a stream, and therefore it has an outlet. Okay, but then on this stream, which I have now got here, which is an outlet, I apply a terminal operation. If I apply a terminal operation, it will return it won't return a stream to me. It will return some value, or even if it's returning a void, it is terminating the processing and getting the results. So if it is a terminal operation, I'm not getting a stream. So what is the intermediate operation? In a stream, what is an intermediate operation? Yeah, any operation, any method which returns a stream, a method of a stream which is again returning some or the other kind of a stream. Fine, that is an intermediate operation, because then it says it's open for processing further. I have not yet done the processing. And a very important thing, these intermediate steps do not initiate anything. They won't do anything unless a terminal has been added. So if you just create a stream and put one intermediate operation on it, nothing happens. You have added another intermediate operation on the further created stream, nothing will happen. Okay, fine, no processing will initiate. You put a terminal, the entire pipeline processes. Only when the terminal is put, okay, then the elements will flow and processing will happen. On applying a terminal operation, the processing would initiate. No processing happens unless a terminal is given. And before terminal, you have only specified, oh, I want this step and then this step and then this step. So these are the intermediate operations which are used for building. What we call it as building a pipeline. See, this is similar to what you might have done if you have used. I think you must have used Linux in your labs. Okay, where if you have used the terminal, right, on Linux. Okay, see, this kind of thing even works on command prompt. Okay, so you can you have some you have something like this. You have got command 1, and then you put a pipe operator. You have the command 2. You put a pipe operator. You have the command 3. Okay, so what is being done? Each command, right? This command generates some output. The lines which are generated by command 1 goes as input to command 2. And command 2 does its own further processing on whatever it has received from previous. And then it will, so this pipe operator is like, okay, let it go further, right? If you have a pipe, fine, then it needs one more operation after that. After a pipe, you must be mentioning a command. But after this command, I have not mentioned any pipe. That means this is my terminal. Okay, I'm terminating. So fine. So with this, it executes the whole pipeline. Fine. It's like things. So it's like from the previous step, whatever elements come, okay, fine, they will be processed by the next step. So you can connect multiple operations by using those intermediates. So intermediate operations are for creating a pipeline, and terminal operation is for execution of the pipeline. Okay. So source, intermediate operation, and terminal operation. Fine, that should be okay. This is outline which has come here. Static method, how to create a stream. So creating a stream is like this. Empty stream can be created, multiple elements. So that's again from array. Okay, fine. You can have a supplier. You can have an iterator. These are methods which have been provided in the stream interface. Stream is part of java.util.stream package. Let me put some notes. It's part of the java.util.stream package. Okay, fine. It's a stream of, so we have in this package we have interfaces, right? These are the 4 interfaces which are stream. There is a stream of T, in stream, long stream, and the double stream. Okay, how to create? Fine. So for that, we have mainly discussed the stream, and some places I have shown from in stream. Okay, but whatever is for in stream, similar thing will be there for long stream and double stream. Okay, most of the things are common across all four. Okay, one more point you should understand here is that these four have a common super interface. So there is one interface called base stream. Okay, and this is an interface. No one, you don't need to use that. It's just because we have certain methods which are common across all of them. Okay, some of the common methods, they have been available in the base tree. Okay, anyway, so okay, let's proceed then. Yeah. So these are so first part is about how do we initially manage a stream. So managing streams will be, yes, you have multiple values. Wherever you have multiple values, you can manage. So some of the other ways of creating a stream, like there is a method called generate is fine, it is from a supplier, but there's also a method called iterate. Fine. Generate is okay, fine. I think you should be able to understand what is generate. Fine. Supplier means you have a get method to get a value. So each time you call the get method, you'll get, so that way it is creating multiple values. Understand it's an infinite string because it doesn't have end. Okay. Each time you call the get method, a new value will be available from the supplier. Okay. So number of elements, there's no limit to the number of elements in the supply in the stream created using a supplier. Okay, but of course we always have the operations, intermediate operations to restrict. Okay, so it's not that infinite objects you will be processing. Fine. How to restrict? Or that will be through the intermediate operations. We will see those intermediate operations also. So we have the method which requires supply. That's a method called generate, and then the iterate method. Let's see what is the iterate method. Static methods. Okay. So these are in the stream itself, fine. And there are so many other places where the methods are available for creating a stream. Okay, so we have the public. I'm not putting all the methods anyway. All most of the methods are there in the presentation, so that you should be that you will be getting. Okay. Fine. So let me explain iterate here, right? So you will get a stream of T. Method name is iterate. Fine. How to create that stream? It says, okay, your first value will be of type T, which is a seed. And then onwards, we will use a unary operator of T. Fine. Which is your giving us the next value. And this we call as a seed and the function. Yeah. Simply a function, right? Unary operator. Clear? So what will it be doing to get the first element? What's the first element in this? Seed. What's the next element? What will be the next element?
Function.
Function dot apply as int. Sorry, dot apply. It's not because it's of type T. Dot apply and seed. See, that generates the next element. What is the next element now? After this? We can keep it in the next line. What will be the next one? Yeah, it's just like, you know, you have the X and then you have f of x, then you have f of x, right? And you have a function, just keep on invoking that unary operator in one input and one output, right? Whatever is the input type, same is the output type. That's a unary operator. Okay, so it's so you have a series kind of a thing, fine, series of values generated from a function. Keep on applying function like this to generate. So this is again multiple values. So what they have, this is infinite again, right? So what they have is they have provided one more, which is added in Java 9. What they said, let's overload and put a predicate. Let's put a test, has next. Okay, has next. Does it have a next, right? For example, you might do a test. I can give for example, you are having a iterator so that it can generate a Fibonacci series. Okay, fine, you have a seed and it's generating maybe some other series, fine. So using the previous value, it's able to generate the next one, right? Fine. So you have this series being generated, but then someone says, okay, I want to end the series if the value exceeds 1000. So that will be your has next. Okay, you have a predicate which will test if has it become greater than 1000, then I should return false. Otherwise, I keep on returning true. Okay, and so that predicate is for that reason. So they added a predicate so that it can be terminated. Okay, and also two streams can be concatenated. You can concatenate. And so these are methods available in the stream. You have other methods. Now this is for int stream. Okay, this is for int stream. Very similar thing. In int stream, the additional thing is about range and range closed. Okay, so when it says range closed, it means 2 is included. Fine, in range 2 is not included, from and up to 2 but not including 2. Okay, static methods in the arrays class. Arrays has this, I was talking about stream method in the array. This is that stream method. Okay, default method in the collection. So in collection of, we have studied collection earlier, right? We didn't look at the default methods then, but it has these two default methods. So if there is a collection, okay, I'll convert it into a stream for you. Fine. So we have a stream method, or you have a parallel stream method. Okay, we have something like, okay, I'm not sure whether you have done java.io package, input output. If you have to read from a file, if there is a text file and you have to read from a text file, you know how to read? Yes, okay, so you know about a class called buffered reader over there, right? So if there is a buffered reader, we got a method called lines. It gives me as a stream of string. So each string is one line in the buffered reader. Fine, buffered reader could even be created for a file also, right? There is this package java.nio.file package. It contains a class called files. Okay, and this again has these methods. So this also is this is actually Java 7 had this package called java.nio.file, which was introduced in Java 7. Okay, and from that point onwards, you can use this class called files, methods in this class called files. For example, there's again an interface called path. So path can be created, and you can you can get a stream of lines, again stream of all the lines in a stream of string as the lines in a file. So these are the various ways you can do it. Okay, you have a stream, you have a list on a, so if there is a fine, given a directory, a path to a directory, okay, fine, given a path to a directory, you can get it as a stream of path. Oh, these are all the various file objects. Fine. Same way, starting point, you can say, okay, let me find everything in this. So that generates multiple elements. Oh, there are multiple path elements. So stream of path. You may not have done this particular package java.nio file, but that so the whole point here is that we got in the whole of the Java library, there are so many places we have methods which return streams. Okay, fine. You have done, okay, see this char sequence. When it says char sequence, it's a string class which is implementing char sequence. You get it as an int string. And I was talking about a string made up of sequence of characters. These are integer values. Okay, here is an int string for me. Fine, you can process them. Okay, there is pattern and matcher classes in java.util.regex package. If regular expressions you have done, fine. Then again, there also we got methods to return a stream. Okay, so stream is there and fine. So I've just stopped here and said, and many more in parts of the API. So there are many more parts of API which has methods to return a stream. Okay, so stream is just one standard place, and then we have given a stream, we have a standard way of processing multiple values. Intermediate operations are methods in the stream which again return some kind of a stream. Okay, fine. Clear? So you can see the return type of these methods. These are methods on a stream object. So if I call filter, I have to pass a predicate, some testing which will be done, and then it is returning a stream. See, what I have done here is this list of methods which I have shown. Okay, let me again go back to that visualization. Let's see the visualization. Sorry. See how I look at intermediate operations. Okay, so I have actually categorized those intermediate operations and grouped them according in that manner. So if there is an intermediate operation in a stream, so here we say stream is just some output, right? Okay, and then you're calling a method, right, on this stream, which is just nothing but some kind of an outlet where elements will be available. You apply a operation, right? So you apply some kind of an operation, and if it is it's returning a stream. Okay, so if it's returning further something, right? So it is having, so it's doing some processing and giving out something more. Okay, so now if I look at this, every stream operation has an input side and there is an output side. Okay, so there are multiple. So what I have done is I have categorized like those kind of intermediate operations where the number of elements in the input side and the number of elements in the output side. The output side may have lesser elements than the input side. Another case is output side will always have exactly same number of elements as the input side. That means the operation here is of transformation. Here, in this case, the operation is of restricting the elements, right? Dropping out some things. Okay. We have methods, intermediate operations whose only job is to do some transformation. It won't miss any element. Every element in the input, for that, I have some element in the output. And we even have those kind of operations where for every element in the input, I may multiply. Each element gets multiplied into multiple elements in the output side. Okay, for example, you have a stream of lines, right? You are reading from a file. Okay, so each file, each line in the file is a string for me. So that's one element. But for each element, I'm now breaking it into words. I want a stream of all the words. I'm not interested in a stream of lines. Let it get converted into a stream which contains the words. Right? So it has a potential of multiplying. Okay, so we have, so accordingly I have categorized and I have grouped those intermediate operations on these lines. Okay, but remember one thing, that file, it can happen that there are too many empty lines, okay, and therefore the number of elements in the input side may be more, but the one on the output side may reduce. That's possible, but it is mainly for multiplication purpose, multiplying elements. Okay, so accordingly I have divided these. Okay, so these are the ones which are restricting. Okay, output side will be less in this case. Fine. Distinct, that means on the output side there won't be any duplicates. Fine. Skip, n number of elements to be skipped. Initial, so many elements will be skipped. See, for example, you have lines, right? And from in this file, there are initial 10 lines which are the header lines. Okay, I'll skip 10. I don't want to process those headers. Okay, and maybe it's not a fixed number of lines I have, but my headers are identified by presence of a colon in the beginning. Some such thing can be there. So you can say, okay, drop while I find a colon in the beginning. So drop while, have a test. So after that, it won't test anything. And once it has skipped and once it has stopped the skipping part, okay, then it will, so drop while, once it has stopped the dropping, okay, fine. Drop while means initial elements will be skipped. It's similar to a skip. That's why I've written it post skip. So skip is based on count, drop while is based on a condition. Okay, both of them drop only initial elements. Fine. Same way, limit, I would like to stop once this has happened, right? Once I have reached the limit of maybe I have 1,000 lines to process. Once I have finished, I've given out 1,000 lines. I don't want to give anything more. Okay, or it is called take while, right, with a condition. Okay, so take while condition means till this condition, as soon as this condition becomes false, it will stop processing, sending more elements further. Okay, and so these are the restricting ones. This one is where we have one-to-one. Okay, no element will be lost in this. Fine. For every one element, there's one element in the input, there's one element in the output. Parallel and sequential, these methods are more, parallel is a method which actually suggests that you should have a parallel. I'll try to give you a feel of what is parallel. For that, we need to also look at one more thing which is related to the collection framework. I'll go back to that. Yeah. Anyway, so parallel, sequential. Okay, these are just some properties of the stream. So from this point onwards, it will become sequential. Oh, from this point onwards, it is parallel. Okay, fine. So parallel, when I say parallel, it means the elements which are coming out, fine, can actually be split for parallel processing. And each part, so if I have 1,000 elements, I may split it into 100 elements of 10 parts of 100 elements each. Okay, it may get split like that, and each of those 100 is being processed parallelly. Okay, so it's using some splitting technique. And parallel means it will be possible to split, okay, and use them. Unordered, so more like the set thing, okay, not following a particular sequence. Okay, parallel is definitely unordered. Okay, fine. So elements will become unordered. Now on close is not doing anything to the elements, it's only adding a runnable, a close handler. So whenever this stream will be closed, fine, then I want to execute certain things. So that can be specified as a runnable function. Okay, fine. If we understand, runnable is also a functional interface here. Okay. Now map is a transformation function. Fine. It transforms each element of type T into an element of type U. Okay, so that's a mapper from T to U. So a stream of T becomes the stream of U. Fine. For example, you have a stream of account and it can become a stream of names. So output side will be all names. Fine. Stream of string. Fine. Okay. Same way, maybe you would like each input element getting converted to an int value, and therefore it returns an int string. So it was stream of elements, but now it has become a stream of int type, stream of some reference type, right? But same way, map to long, map to double, right? They require, see, they need a function to do the transformation to that new type, whatever the type of string, new type of string you want. So these are transformation of elements, map methods. Okay, map to int, map to long, map to double. We have the method called peek. Okay, fine. The peek method doesn't do anything. It is just taking the element. You can write a function to carry out some operation, but whatever element coming in the input will go to the output as it is. No transformation to be done. Okay, only thing here, this method is mainly used for debugging purpose. What we normally do is we just try to print the element so that we can see what is flowing out in the stream. What are the elements which are going out? Fine, you want to do some debugging and find out, oh, what's going wrong somewhere, or why this where it is vanishing or something, maybe some element you expected but it's not coming. Right? So you may use peek method in various parts of the pipeline. So just introduce a peek, and in the peek, what is the action you will take? Okay, given that element, let me print the element. Right? Consumer, right? So given an element, I would like to take some action on it. Fine. Sorted. So after this point onwards, the elements which come out will be in a sorted order. Now this one, the sorted method will convert your stream into a sequential one if it was not sequential. Okay, sorted is definitely making it sequential. Okay, so 1 to 1, and then these are the ones which will do a multiplication. Right? Each one is capable of one element multiplied into multiple. And this is the method called flat map to int flat. So when it says flat map, what it says, given one element, can you give me a stream for the type u? So you should be, the input should be one element, and output, the function's input is one element, output is a stream of elements. So then it becomes a stream of the new type of elements. Okay. These are some more methods which are again with multiplication kind of a thing, which have been added in Java 16. Java 16 added this map multi. Okay, it's called map multi, or map multi to int, map multi to long, map multi to double. So what it does here is, here what is needed to be passed is a function. You can see it's a by consumer which is needed, by consumer of t and consumer of r. So it becomes a stream of r. Okay, maybe I'll okay, 1 second. Let me just go through. This is again I have repeated for int type, int string. This is a repeat for the int string. This again has the map multi. Okay, here the parameter was int map multi consumer. See, this is not a standard function interface, and but this has been, this is the second parameter here. If you look at this map multi method in the int stream, right? Fine. Map multi, first parameter is in-stream dot, so it's an inner interface within the in-stream. So in-stream has a further interface called int map multi consumer, okay, which is again a functional interface, but this is not in the standard set of function interfaces. Int map multi consumer, okay. So for that, what is the method in the int map multi consumer? Fine. Is this, there is a accept method. It's a consumer. So from that point of view, they have given the method name as accept, and the parameter, first parameter is value and second parameter is the int consumer, okay. See, it could have been, they could have actually managed without this. It's only that we got a standard function interface which is similar to this with the, for example, we have the obj int consumer. If you recollect, there is a obj int consumer. It could have worked, but only different there is, in that case the int is a second parameter. Here they have wanted int as a first parameter, and therefore they created a new functional interface for this. They didn't pick up the standard function interface. In the standard function interface, we have something very close to this int map multi consumer. We have something called obj int consumer, okay. Obj int consumer of int consumer, that could have worked, but then the parameter sequence would be different. Okay, how to use them? I think I'll have to show how to use all of these methods. Let me just check what all things are there. Then the terminal operations would come. Okay. Terminal operations would return a single value. Okay. So there are these terminal operations returning a boolean. Fine. So 3 of them. Fine. These are the ones which return some kind of a statistic. Okay. Fine. What is the count of elements? Min, max. Okay. For in case of in-stream, long stream, and double stream, we can even ask for the sum and average as a terminal operation. Fine. Finding elements, so finding the first element. Okay. So, but these are terminal. As soon as a terminal operation is done, the entire pipeline is closed. Remember this, okay. When a terminal operation executes, after execution is over, it has processed, all the streams in the pipeline, every stream in the pipeline is going to be closed. So if there is an on-close handler anywhere, it will be executed. Remember also that, right? So these are find first and find any. The difference is find first is for a sequential one. Find any is for the unordered one. If it's unordered, you will just say find any. So these are about getting the first element, any element. But okay, if the stream is empty and therefore the return type here has been shown as optional. When in case the stream is empty, it doesn't have a value, and therefore it says, okay, I'll return optional here. It's not returning null, okay, in case of no values. Okay, fine. Again, for each and a consumer. So process all the elements, and here is the action to be taken on each and every element. For each, ordered, right? So ordered is for sequential one, and for each is for unordered one. Okay. Convert them into an array. Fine. And in Java 16, they have added one more method called toList. All the elements can be taken out in the form of a list. Okay. So we have methods. These are anyway terminal operations. Terminal operations, they'll find, so on any stream, right, you can just apply this. Okay. Yeah. Which one we should take? Let's see. Okay, we can do some exercises, right? yesterday's thing, I think there are a few more things which are pending, which we didn't do today. That's too much. Okay, one more thing, like for tomorrow, you should be prepared for a longer session tomorrow. Okay, and because I think we may need more time to cover up all the things. Okay, we'll do exercises tomorrow, maybe. Or you want some specific to be done today, something which is, and you want me to do that? Okay, first thing, there are those methods called stream which are available in the collection. Okay, I'll go back to the collection and take some more methods of collection because they were default methods which we didn't cover. I'll just talk about. These are the default methods, okay? Return type void. Name of the method is for each. Parameter is a consumer of E. Okay. Yeah. And this is one very commonly used method. It's method available in collection. Okay. You see, it's also available in stream. I'm not currently looking at that one, but I'm looking at the one which is in the collection. Okay, let me list the other default methods. Default method. To return a stream of E, there's a method called stream. There's a method called parallel stream. And we have a method, I think return type void. There's a method called remove. Picks up predicate on. Okay. Fine. See, what is for each for? And you know, you have been used to writing a for each as a loop, right? For each account AC in accounts, where accounts may be a collection, okay, or something like account map. You have done that, account map dot values, right? I think that was done in the list. Okay, so what do we do here? Whatever, there are some processing steps here, right? And this is how you write maybe system.out.println. Suppose this is what you were doing, right? See how this can be done. And as a consumer, it's as good as this. Getting the point? No. And how, see, this is this for each is a different approach. Earlier, the approach was, what was the approach in this for each loop? The approach was to take out the element from the data structure and then use it directly here. Fine, you have your variable AC where you are able to get the account object. Okay, This is supposed to be more error prone. Fine, this can lead to sometimes wrong coding can lead to errors, but fine. The whole point is the approach, how it has changed. You have a data structure. From the data structure, you are taking out the element and then processing it. Fine, doing some processing work on it. The other approach is, okay, I know what is the processing to be done, right? I know what is the action to be taken. I want the data structure to take the action on every element. That's a for each. This is that for each method. So what do you pass as parameter to the for each method? The action to be performed. It's a function. I give this function to you, okay, and you take the action for on every element. Clear? The approach is different. Clear? You are not taking out any element to do the processing, but you tell this is the processing to be done, give it to the data structure so that it finishes it. Okay, so same thing with stream. Stream, you are just giving, okay, this is what I want you to do. You in stream, you are not extracting elements. Okay, here with stream, you are not even extracting elements. You're just saying, okay, this is what is to be done for every element. You're just mentioning the step to be done, processing, what is the action to be taken. Okay. Since 16. Yeah. Map, flat map. Okay, now one of the things to be done and is that in the exercises part, right, the to do part, we have to return a stream, okay, return a stream of account or stream of transaction in the account class. That's a change, right? So can we do that now? This is account and one of the two. Let's see, just complete the two. Okay, that is currently not done, but this one, and this method. Okay, let's do that. Public stream of transaction. Okay, get transaction stream. And what do we do? How do we return the transaction stream? Fine, just use the stream method and return. Fine, so this is as simple as that. Okay, so because similar thing is also required in the bank class, you can do that. Add a method called get account stream. So we can do that. We have the map. Okay, I'll just put it here itself, public return this dot account map dot values. Okay, and so this is, it's something like this. Clear? Okay. Now with this change, okay, now with this change, it should be possible. Why I have asked for these methods specifically is you want to try out the methods of the any methods related to stream. It can now be done easily even in test bank and test account. This is test account. We can actually do it in test bank now. So in the test bank, right, wherever you want, okay, this is, okay, yeah, here. Add a method in account class. This is done. Acha, has penalty. That anyway can be done. Display all accounts which have a penalty. So first thing, you need to add a method called has penalty. Okay, how do we do that? In the account, we want to have a method called has penalty. Yeah. How do we return whether it has a penalty or not? Transaction type, right? We have the transaction type. What is trans type? Credit and debit. Does it have a narration? I think it has a narration which will. Transaction has a narration which will be having penalty, right?
Yes.
Okay. So we check the narration. Yeah. So we can use stream here. Don't need to write the for loop. Okay. This dot passbook stream, or you can even say get transaction stream. Okay, let me put the stream here. When you got the stream of transactions, on that, yeah, not filter. You can just say has penalty, right? Any match. And what's a predicate? Yeah. Given a transaction T, okay, T dot get narration dot equals ignore case. Okay, so return this. Sorry. See, it's a one-liner. You're seeing how it is done. Stream dot any match. I'll put this in the next line. Okay. Yeah. Fine. Just stream, and then you can say, okay, does any of the entries match this? And here is what it is. This is my test. Simple. See, one line you are able to finish. Fine, this is the terminal operation, returns boolean. Any match, none match, all match. Okay, and those were the methods returning boolean. So all the entries match a particular. This is your test, basically a predicate, right? Predicate means input is some transaction, and for a given transaction it returns a boolean value. Okay, that's the expression on this side. So has penalty, this is how it is to be done. Add a method in the account. Okay. Display all accounts which have a penalty. Now, can you do it not or not?
Yes, sir.
Right. Bank dot get account stream. We created this method so that we can have streams here. Okay, on this bank, let me get the account stream, and now fine, you can write your code here. Okay. Which have all accounts which have a penalty. So you say filter. Fine, you want the filtering on
Accounts.
account should have a penalty, right? So this is an intermediate operation, filter. We have to put a terminal. What's the terminal? Dot for each. And you want to call the display method or want to call the print display all account. Want to call display method, in which case you will say account colon display. Okay, and this is one way of doing it, or this could be, so you can either do it this way, or you could be calling the okay. Fine, either of them is fine. This one is dependent on the toString method. Okay, I think we should prefer this one. And just so that I show you the choices. And so like this, get list of account with penalty. How is it different from which we have done? Achha, get a list. So you need to have it in the form of a list. Sort the list on different criteria. Create a, okay, anyway. Some of these will require the advanced usage of stream. Okay, grouping by and all those things are needed. Anyway, there is something called collector which is important. Right? So that is quite powerful, and we should be able to use that also. Anyway, yeah, we are running out of time. Anyway. Anyway, any questions you have? Yeah. Yeah, anyone has questions? Okay, fine, you can try the other two do's now, right? So, some of the things you can further try out. Okay, and okay, there was that penalty as an interface, function interface to be created, and then it was to be used in the current account, right? Anyone has attempted that? Functional interface called penalty. I think there's a to do. Somewhere it is there, I think. Penalty as a function interface nahi hai. Oh, it may have remained in the account name. It would be in the current account class probably. Or it's in the test account. Just check. There is a to do in the test account. It talks about setting a penalty function, but define करने का कहाँ पे बोला है? Actually, I have given even the lambda for that. Okay, let's check. It may have been in the to do, maybe I have remained in the current account class. इसमें है to do नहीं है. Okay. Basically, there is the idea that we should have a this one is this. See, this penalty here is a long type, right? But instead, we don't want this. So yeah, it remains that it's over. Anyway, so. See, the whole idea is we don't want to use this static variable of type long. Penalty is not a fixed value of type long, but we want penalty as a function, right? So for that purpose, a function interface is necessary, and that function interface we'll call it as a penalty. I think yesterday I did show us like some kind of rough code for that. Okay. So anyone has attempted it?
Yes, sir, I have attempted, but implemented it in account class for all savings and control.
For all, you have done it in account class. Acha. Because minimum balance is something which is in the current account. It's not in the account class, and therefore it was supposed to be here. Anyway, it's fine if you have done it there. Fine. Okay. So any questions still? Okay, we'll call it a day then, yeah, and continue tomorrow. Yeah. Okay. Okay. And so thank you everyone.